Okay, my friends, it's Roger once again, and I'm going to tell you right now. You see all these different elements on the periodic chart? Well, guess what? On other planets and other worlds that have different gravity, you don't have the same elements. Oh, Roger, come on, come on. I said, no, I don't think so. Here's why. Because here's what's going on. There's Schumann frequencies. There's 7 major Schumann frequencies. Our heartbeat and our literal electrical biological rhythm is the Schumann frequency 7.83. It's exactly. I am going to explain this to you. Now, the reason is because of the gravity of the Earth. We're going to go to the big board in a second. We're going to look at why these Schumann frequencies occur. Because they're boom, 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 and then they go to the Earth. Boom, boom, and it's just continuously. And they are discharging electricity into the Earth every so often, and that pulsates into a frequency of 7.83 hertz. Now, if you have a different gravity, and the pull is not the same, the Schumann resonance will not be the same as it is here on Earth. So instead of 7.83 hertz, it might be 15.6. And you're not going to do well in that. And as a matter of fact, I put out a thing saying I want somebody from NASA or somebody to tell me, do they put in these Schumann resonance frequencies? And that, yes, they do. That's what I was told. And if anybody can come up with something different, I'd like to know it, or somebody can prove that, yes, that is. But I did get something, an article or whatever it was about, it went back quite a ways. And they found that they got sick. And they couldn't hold up in that different frequency. So they had to put in the Schumann frequency 7.83 hertz, or I don't know what they did, but they made it so that it simulated the Earth pulsation. And we're going to look at it right now, and I'll show you the pulsations. But here's why I say the actual molecules themselves. In electron flood theory, can you see that? Yes, you can. The nucleus is made of electrons, and the reason they nucleate and congeal is at certain quantities, and then they lock in. And I'm going to show you that happen right here. So if the frequencies here are from the size of our Earth, which they are, the frequencies that create the Schumann resonance is because of us plowing through and spinning through, and the electricity discharging every so often through the ionosphere, magnetosphere, whatever you want to call it out there. One of those layers is getting saturated with electrons, and boom, saturated, boom, every 7.83 hertz. That's what is causing and then it hits the next layer. We'll go over there, well, we should in a second, but let's look at this first. This is what creates molecules, is a certain frequency, and because there's a bazillion particles, and every one of these is an electron in my world, there's salt. But salt is nothing more than exactly what an electron is. It's a strong force and a weak force. And you say, well, Roger, how can you say that? And here's why I can say that. NaCl. You see that? One side and the other side. NaCl. It's an extremely polar molecule. And what is an electron? It's 100% polar. It has a strong force, which we would call the negative, and then it has a weak force, which just does absolutely nothing at all. But it counteracts and it attracts the strong force. But other than that, it does absolutely nothing. It doesn't interact. It doesn't do anything. But it's gravity. It gets a little bit complicated, but it's really not that complicated. Now, watch what happens here. As this thing vibrates, and what is a vibration? A vibration is pushing air and dropping it. Push, 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 push. And what is that in my world and in your world? It's pushing electron to electron. Let's go look, well, let's do this first and then we'll look at the big board. Here goes. Here, I want to tell you something. I fly this thing off at the cuff. Obviously. Now, and that's what I'm going to do from now on. No more, because it's been take me a long time. I got to put it together, and I make a mistake. I put it together. I got to throw the mistakes in. I don't care anymore. If you want to stick through it, because this is how I'm learning. I'm learning right now. You know, I mean, I understand this part of it, but as I go through it, I learn every second, because that's why I'm doing it, to learn more about it. Because every day I learn a new little thing about electron flood theory, or about the Earth, or about Schumann resonance, or about how other planets are interacting, or about something changes the mix almost every single day. So stick with me if you want, or don't if you want. It's up to you. Now, this is 15 million hits brush cup. What favorite guys. Now, again, they're injecting a vibration in here, and to us, a vibration is a push to shove of electrons. So it's like a negative, positive, and that's really all it is. So here it goes. Here goes the salt on now. Now they're going to go to a very low frequency. See, vibrate the metal plate by using a tone generator. When you vibrate it, it goes plus, minus, plus, minus, plus, and literally that's exactly what it does. And it shakes the salt, because they're plus minuses. The pitch of the tone increases, geometric patterns will form and become more complex. The more frequencies, the higher the frequency, the more complex the pattern. And these are the electrons. Every salt particle is an electron in my world. Here goes. Now they're way down in a low frequency. Boom. In the periodic table, that is the first group. That can have 2 electrons here, or it really could have 4, but I believe it only allows for 2 or 1. So that's our lowest group. Then we go next into this one, and literally that's what's happening. Watch. So we're at 345 hertz. So it's bzzz, and oof, they lock in. Now, boom, there it is right there. That's our perfect lowest orbitals. Then we go up into what's called the rule of 8. And you're going to see 8 of them show up around here. You see it? Absolutely flawless, 8. So that's row 2. Row 3 is going to add another layer around it. It gets a little more complex. That's row 3. All right, but there's still a rule of 8 plays in here. Then you go up to row 4. And that is really literally what they're doing. Row 5, row 6, row 7, row 8. They're going to go up through them. See that rule of 8 pattern showing up? And then it gets very, very, very complex. But all it is more and more and more electrons. And what would that mean? More and more and more gravity is in because every dark particle is a piece of gravity. And every time you have a light particle, which is one of these, you have a dark particle with it. So, and it just keeps getting heavier and heavier and heavier. That's what gravity is. The dark particles are the gravities. Look at that, rule of 8 again. I mean, it's absolutely unbelievable how complex it can get. And now, all right, so we're seeing all kinds of complex activity in what I call the nuclear structure. You have to call it the nuclear structure. And she keeps adding more and more electrons because you get more and more and more frequencies. Now, I'm going to show you this in my magnets, but I was going to make a point, and here's what happens. I get lost. Give me 1 second. I'll remember what I was going to say. All right, I remember what I was going to say. These are the dark centers, are literally dark matter. That is where you have an interaction of the shake and push to shove, and it really glows there. In light, that would glow, that would be dark. And you can say, oh, Roger, how can you say that? Well, here's how I can say it. Because these are nothing more than magnet balls. They will have a dark, and well, I'm going to show it to you right now. I'm going to remember these patterns. Dark with the light all around them, swirling all around these things. You saw them, all kinds of different patterns. Well, we're just going to take a chunk of different dark matter balls. Like this would be just like this. That's what that is. All right? It has energy around it, and there'll be a dark spot in the center. And I'm going to show you that in this magnetic tape or whatever they call this stuff. You put the magnet behind it. Well, here, watch. You see this big magnet? And you're going to see it'll be dark in the center. This is nothing more than one of those like there. Watch. See, it's dark in the center and the white. See? No difference whatsoever. A zero. Zero difference. No difference whatsoever. And when you get into the complex patterns, same thing, no difference whatsoever. I hope you can see that. Well, if you can't, I don't know what I can say. I don't know if that helps. But you can see how complex those little patterns are. I can see it quite well here. But they're all there is no difference, none, zero, zero, absolute no difference whatsoever. Now, what does that tell me? That tells me that we have regions and zones of energy that are here only because of the frequency that they are pulsating into this right now. That's the only reason this exists in that pattern like that. If it was at 4,000, you would have a different looking pattern that wouldn't be locked in. Now, if other planets don't have the same Schumann frequency we have, and they're not gonna, because it depends on the size of the pull of the gravity, how many black balls you have, to how much frequencies you're going to create. So you're not going to have the same frequency, because we have 7 here. Well, let's look at the big board, and that'll make it more understandable, I hope. This is confusing, and I don't think anybody understands this, so don't worry. You're not alone. Oh, am I glad I didn't erase all this. I was just getting ready to erase the whole thing and go into a whole new area, but these are the Schumann frequencies we're talking about. Here's the Earth. We are spinning through space, and space is loaded with particles coming from the sun to heat us up and warm us up, and they push to shove at our atmosphere edge. So we're scrubbing our atmosphere against these particles that are crashing against us. And it's extremely hot out here, and it creates a lot of electrical discharge. It's called the ionosphere. And then you have the magnetosphere, and that's what creates the magnetism. You see this? In my world, you have a strong particle and a weak particle is the electron. You see it? That's an electron. Only the white part pushes. The black part does nothing at all. When they get together like this, as I've shown 100 times, 1,000 times probably, they are a photon. Photons bang off of you. They don't try to incorporate into you. These try to incorporate into you, electrons, and they will warm you up and they will burn you up if there's enough of them hitting you at the same time. These will bounce off of you. They'll warm you up, but they're not going to kill you. These will kill you. Now, what happens here? The sun spits them out here. Zoom. They smash into our atmosphere that we're scraping against, and the push one pushes against ours, because we got push ones too. So it's push to push, and that one is, I call it push to shove now, because it pushes and that shoves back. Well, that has to shove off of something, so it pushes that one. So it's push to shove. That one pushes down to shove, push to shove, all the way down to the Earth. And there's 7 Schumann frequencies, and they go 7.83 at the lowest frequency to Earth. That's where we exist, in this frequency. And everything in this frequency pulsates because of that particular frequency. Now, if the Earth was half its size, this will be, let's say, 100 hertz. It'll be, I don't know what is going to happen. But I can tell you right now, this is what creates the stability of our biological life. That's exactly identical to what our heartbeat is. Now, what happens if for some reason that changes on Earth? What would that do to us? I don't know. It might make us 10 miles tall. I have no idea. But I can tell you one thing. we are entering some form of a different area, or something's changing in our atmosphere. And there's a couple things I realize are going on. One of them is that as we continue to scrub through all these electrons, which are out there, they say, oh no, there's nothing out there. They're crazy. Obviously, they're coming from the sun. There are electrons out there, photons, particles of all kind of nature. We're scrubbing against it. That's the only reason it's so hot out here. It's thousands of degrees. It's 100 or so on Earth. Now, so get past all that. There's a bazillion particles out here. Scrub. Vibrate, push, push. And then the Earth is supposed to absorb them, spit them back out through the poles, and then they get scrubbed again and discharge. And it's 7.83 hertz is this scrubs, it builds up electricity, discharge, 7.83 hertz. Scrubs, discharge, 7.83 hertz. Scrubs, discharge. That is what creates the pulse of the Earth. There's no other reason that electrons should vibrate like that. Like I showed in that vibrating plate thing. So that thing had a thing that made the plate vibrate. This is what makes our plate vibrate right here, is the scrub and the electrical discharge. They know that. They know that's the Schumann frequency. There's no question about this. And there's no question about these distances. And there's no question there's at least 7 of them, and there may be more. But whatever that distance is related to the pull of the Earth and the scrub through those particles. So if we scrub harder, that's going to change this. That'll change this. If we build up more and more electrons in there to keep pushing back harder, which we are right now, that's creating these sprites and blue jets that are trying to push the electrons back up because we don't want them anymore. We don't want the damn things. We're so loaded up down here. We're overheated. We have fires. We have hurricanes. We have floods. We have tornadoes. We have all kinds of disturbance, which is anytime you have disturbance, anytime you have energetic reactions, it's push to shove, it's excess electrons. Basically, it's excess electrons. If you suck electrons out, you get cold. That's all it is. You take the electrons back out. Well, we can't get them out. They just keep coming, and there's so many of them now that we can't. The Earth used to say, okay, send me your electrons, I'll take them out. Well, now we've pushed so many into the atmosphere that the stuff coming, us pushing, boop, they're trying to get back out. That's what a red sprite is. If you see these, it explodes like an atomic bomb going out, and then the whole thing glows like right up like this, red glow, and then it trickles back down because it can't take them. But we're seeing events now that have never been seen before. Blue jets, those are even stronger. The blue jet goes up, the red goes up. They're push to shove. I hope that made some form of sense. All right, because I say this one pushes and shoves. All right, bang, it's pushing against this layer, which is our layer of atmosphere. It's pushing, this is getting pushed down, this was shoved back, but it has to shove off of something, which makes this one pushed. This one pushes, that shoves off of that one. Push to shove off. Now, the reason the lowest frequency, I believe, is 7.83 is because this is like a redshift, because it's supposed to take in these electrons here, so there would be no pushback. This is a pushback. That's why you only got 7.5. 7.83 is an elongated one where it's not crushing it. There's nobody crushing against it because the Earth is supposed to take it. But what if now this is going bad because the Earth won't take them anymore? And we're supposed to be at this exact 7.83 and it goes to 5. I don't know what happens. I have no idea. But these are the kind of things that we should be thinking about. Because here's the things that affect the Schumann frequency. Density of the medium. How dense is it? How hard are we scrubbing against this? How dense is this? How hard is that pushing against this? How hard are we pushing into it? How hard are we spinning? How hard are we turning on our axis? What is the tilt of the axis? And I'll show you how it plows through, and if it plows on this way, it changes the way anyway. And there's a ton of different things that affect this particular Schumann resonance. And the main thing is how much gravitational influence is here. How much is trying to pull these electrons in. And what's going to happen to us if this gets completely way out of whack, which it might be. These are the things I'd like to look into. And there's not a whole lot of research on it, but I hope that made some form of sense. All right, I need you to understand that all molecules vibrate. And you say, well, why do they vibrate? Well, what makes them vibrate? It's the Schumann frequency. It's our Earth's magnetic field vibrates like a drum. Listen to this. That's the poles where the fields are shooting out. Right, there's an outer boundary where we smash into the oncoming particles. And it creates just like the surface of a drum. Boom, 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 boom. And that's because of the electrical discharge, I believe. There it is right there. Push to shove, push to shove. Boom, 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 push to shove. And that's why you get all of the different frequencies going down, because this pushes that one, that pushes back at this one, but that has to push off of this one, and so forth, and boom, 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 boom. And now, and the key is the density, really, let's call it density, which is the dark matter density. All right, don't forget now, let's go back to here. I say that everything is constructed of these particles, which are electrons. And the weak force is the dark matter. It's the carrier, it's the pole. It doesn't react, and I have shown that, and well, I'll show it. Well, let me just show it to you now, just so that if you haven't seen it, I'm sure you have, but let me show it to you just to be positive. Okay, I'm going to go real fast through this because I really have literally dozens of videos already about this. Now, that is just normal light, red pulse laser, and that is the acceleration of that, and it pulls itself forward so fast that the particle that's within it comes out, and then the particle concusses. And remember I said, there's a white spot and a black spot. And the white spot explodes into more whiteness. The black spot rolls around and does this. And here they are, actually. Here's the particle. This is exactly what it is the photon. Okay, the dark and the light. And the dark spot is gravity. Now, when it hits at the Venturi, it explodes. The black, which is the dark matter, walks away from the explosive, which they would call the fermion, the electron, really, the electron shower. And that's the electron showers, because that's what's coming out of here is virtually electrons. All right, now don't forget, this is the red pulse laser. That's the accelerated particle. That's where it concusses, and I'm going to show you the black dark energy, dark matter, walk away. And then it comes back after a certain period of time of complete separation. There is absolutely nothing but white particles here. And the black ones, there is none, zero, none. Not a single one in here. Let's show it in a little better detail. Just so you see, we have it in green too. Photons are photons. They're back-to-back electrons. And an electron is just like this, and these try to flow as electricity and so forth, but they always want to be with another electron, or they want to be incorporated into something. If they are not, they're going to try to fuse in there, and that's what creates sparks and electricity and explodes things, because they want to be part of the particles that they're hitting into. These bounce off. Green, red, blue, whatever. And you see them here, like over here? They're the same particles, but they don't. These Rod Warren did this experiments. He discovered the Venturi quite by accident, and I noticed the shots he was getting, and I went totally off the wall, crazy, because I knew what he was looking at. And then he worked with me for a very long time, did a tremendous job, and And the work speaks for itself. Now there's the particle that had accelerated, and once it hits here, this is a venturi, which means that there's two round metal drums that go in like this, and it's hitting in between. And all of those particles that were those big waves, they have to get down to get in here. And there was a little tiny particle in the middle of the big wave. And I have one here, it is right here. This literally is what we look at when you see a photon. This was what was coming towards this slit here, and all that existed was the particle in the center, and the white one explodes. It does not want to be around any other white ones. If it comes in and crushes the other white ones, you get this. The black ones are the dark matter, dark energy. They just walk away. Look, there's no big deal for us. Let's just get out of the way and we'll come back later. And that's exactly what they do. And there is 100% zero black here. None, zero, zero, none whatsoever. However, consider this. Let's get it. I have an even closer shot of this. Now, I told you that these white ones, the reason they're exploding is because they don't want to be next to it. When that's push to shove, and anytime you see that and you see a glow, it means there's an energetic reaction. There is absolutely no other reason for anything to glow other than the two white particles pushing against each other. Now, the harder they hit, the more they glow. However, the black ones we see have just walked away. It's just totally walked away. There's like there was nothing to it. Totally gone out to the sides. Now they come back in after what they would call the interference patterns. They think they're going like this. This is single slit, and it's a venturi, and it has nothing to do, and even the double slit, you can do it on a single slit, doesn't matter. Let's just go past that experiment because it doesn't work the way they say it works. We have a region here, which I say is energetically a bazillion times more energetic than it was just before it hit this venturi. There's no question whatsoever. And if you can harvest this section here somehow, whether you put down some kind of a substrate, something that would absorb that energetic value and funnel it off, and then, it would be separated from the non-energetic value. Because this really, the black one seems to absorb the energy of the white one. Anyway, like I said, I'm sort of musing through this and learning for myself, but I can tell you right now, the whole description of dark energy and dark matter is that it does not emit light, which this does not. These black ones, they do not absorb light, which they are not absorbing anything. They don't really interact, which they are not really interacting. They don't, excuse me, they don't reflect. The only reason we're seeing them is because we're seeing some energetic particles behind them, and they're just obscuring them. They're not absorbing them, they're just in the way. They don't absorb, they don't emit, they don't concuss, they don't do anything other than they are the gravitational attractors. And once you they start to attract, more and more will attract, and more will attract, and then it will just form zones of matter in the universe. And that's what collections of planets and moons and stars and all that are. They're these particles, and the only reason they're stuck together is because of the black part. And that's the only thing the black part does is stick stuff together. There's no other interaction whatsoever. That's the dark matter, dark energy. And now they say, they always thought that this white had to equal that dark. Now they say, no, it doesn't. The white doesn't necessarily equal the dark. As a matter of fact, they say it doesn't at all. And there's a lot more of the dark than there is of the white. That's what they say at this moment.